Hello again, everybody, and welcome to this video. Today we're going to look at addition of probabilities. Another way of looking at it is situations involving the word or. So I want to review two very important terms before we get moving on to the examples. The first one is mutually exclusive events. Okay, so mutually exclusive events are events that cannot occur at the same time. So it's impossible for them to both occur at the same time. So an example would be taking a math class and an English class at the same time during the day. So if your period 1 class, it's not going to be a math and an English class. It's either a math or it's an English. They can't occur at the same time. So visually, Venn diagram wise. So Venns, you'll remember that from one of our previous chapters, this 2 chapters ago. In a Venn, that would mean that there is no overlap. They can't occur at the same time. Also now, then define the probability of this. Now, reminder, these are OR situations, so we're going to use that symbol there, which, if you remember, is union. And again, union and OR go together. So to figure out these probabilities, or the probability of this or that happening, we would add the individual probabilities. So that would be the formula in this case, okay? Non-mutually exclusive events. These are events that can occur at the same time. So in this example, we could talk about taking a math class and an English class at the same time, in the same semester. So that would be possible. You could have period 1 math, period 2 English, right? That's possible. So when we get to a Venn diagram now, in the Venn, there would be overlap. So if this is A and this is B, so we can see this is overlap. And if you remember, that's the intersection. And we use that notation to represent it. So to determine the probability of A or B happening, which is what we're going to be doing, these are OR situations, we would still add our individual probabilities. But then we're going to subtract the overlap. Okay? Because we don't want the double counting to occur. So again, we would count this middle section here twice if we add them up individually. So that's why we have to subtract that amount one time to get back to just counting everything once. Now, in the previous question, or sorry, the previous term, the mutually exclusive events, I showed you how you didn't actually need what I just circled in red there, this part. So there's technically 2 different formulas. I'm going to say, though, let's use this formula every single time. And then if it's mutually exclusive, just that last part, there won't be an intersection, so that'll be 0. So now why I'm suggesting that is just that it's, less to remember. So it doesn't really matter. By all means, use both formulas, but you can just use this one and use a 0 whenever whenever those things can't occur at the same time. Example 1. A card is drawn from a standard deck of 52 cards. Determine the probability that, and again, I'm using the same kind of slide setup, so I'm going to put my A's and B's here. A 9 of diamonds or a heart is drawn. Okay, so what you could do if you really want to get technical with all this stuff, and I shouldn't say technical, proper with all this stuff, event A would be a 9 of diamonds, event B would be this heart we're talking about. So we're going to look at the probability of pulling a 9 of diamonds or a heart. And remember, that's just the individual probabilities added up together. And like I said, then we're always going to use this back part, and that's the subtracting when both those things can occur. So the probability of A, what's the probability of pulling of 9 of diamonds? Well, you have to ask yourself, how many 9 of diamonds are there? Well, there's only one 9 of diamonds, right? So we'd say 1 over 52. Now, how about B? B was heart. What's the probability of pulling a heart? Well, how many hearts in a deck? Well, there are 13 hearts in a deck. So 13 over 52. And then now, how many hearts, how many 9 of diamonds that also happen to be hearts? Well, there is no such thing of a heart that is also a 9 of diamond, meaning those are mutually exclusive. So then I can just go 0 out of 52, just using whatever denominator I've been using. And then when I add that up, I'd get 14 over 52. So the probability of pulling a 9 of diamonds or a heart is 14 out of 52. Now let's look at a 9 or a heart is drawn. Okay, so again, let's get proper here. I'm just saying now a 9, and event B will be a heart. Okay, so to determine the probability of a 9 or a heart. So remember, when you say R, when you see R, that's the unions. We're using this notation. Whenever you see that notation, hopefully you can remember to add your individual probabilities and then subtract that intersection, the times that it can both things can occur. So A is pulling a 9. How many 9s in a deck of cards? Hopefully you remember there's 4 9s, so it'd be 4 out of 52. B is pulling a heart. Well, that won't change. There's still 13 hearts, so that's 13 out of 52. And then now for the last part again, right here. How many 9s are hearts? Well, there happens to be one 9 of hearts, right? So we'd subtract 1 out of 52. So then I'd get 17 minus 1 is 16 out of 52. And yet we could reduce it, but I'm not going to worry about it right now in this video. So we get 16 over 52. Okay, I can't help it, math teacher in me. That'd be 4 out of 13 as well. Example 2. Jennifer rolls 2 4-sided dice. Determine the probability that A, she will roll a sum that is either 6 or an odd number, and then B, I will read later, but there it is down there. Okay, so we're rolling 2 4-sided dice. So I'm not sure if you know all the outcomes that would happen with 2 4-sided dice. So why don't we, whenever you're kind of presented with a problem like that and you don't really know how that would shake down, then just draw yourself a little sum table. So use yellow here so it shows up on my colors. So that would be dice 1, this could be dice 2. And like I said, I'm saying it's a sum table. And the reason I'm saying sum is that it says sum right here, and hopefully remember that sum means addition. So now I'll just go through and add these up real quick. Not a big deal. And you don't need to do this. You can think your way through this part, and maybe you actually know all the different outcomes and stuff. But if you're not comfortable with this idea, then just draw it out, and then you have something to look at. So let's get proper again. A will be a sum that is either 6, so a sum of 6. And B, I guess I can just write odd sum. Okay, and then again, you see that it's an OR question, so we know it's a union, or union. So I'm going to add the individual probabilities. Then I'll subtract that overlap, the times they both can occur. So the probability of A, how many sums of 6 do you see? Well, if I go through it, I see that there were 3 times I had a sum of 6. So that's favorable. Now total outcomes, so how many different outcomes are there possible? Well, all of these are the outcomes. And if you count them up, there's 16 of them, so it would be 3 out of 16. Now for B, an odd sum. So let's go green. I think that'll show up okay. So odds, that's an odd sum. That adds to an odd. That adds to an odd. That adds to an odd. And keep going here. If I count that up, 1, 2, 3, 4, 5, 6, 7, 8, that'd be 8. So half of them. So 8 out of 16. And then now we're going to look for the times that we have a sum of 6 and they're an odd number. Well, if you think about it, there's never, 6 is not an odd, so it'll never happen. I can also go back here and look, and there's never a time where I have one number circled twice. So you can see the 6s are circled in blue, then those odds are circled in green. They're never circling the same number. So it'd be 0, and again, I just keep the same denominator I've been dealing with. So then really 3 plus 8 is 11, so 11 over 16 is the probability that that would happen. So we can use the same sum table as we move forward, but I'm seeing I've kind of marked it up so much, I might have to draw one more. B, anyway, should roll a sum that's either even or greater than 5. Okay, you know what? I think for clarity, it might just be easier to write this out again. Good thing you're watching a video. You could fast forward a little bit, take a break, go get some water, whatever you want to do. I'm trying to just talk to fill some time as I'm writing this out. There we go. Okay, so that's kind of my what I can work with here. Again, ooh, yellow. Let's go blue. Okay, A is going to be the first part. That is an even sum. And B is going to be greater than 5. And I guess that's a sum. That is greater than 5. Ooh, look at that use of the inequality sign, people. Nice. Okay, again, it's an OR situation, so OR is union. So I'm going to write out my little formula here. And again, if hopefully you remember some of the previous chapters, and this stuff will make a little bit more sense. So now probability of event A, and we're saying event A is an even sum. So let's look at all the even sums. So 2, 4, 4, 6, 4, 6, 6, 8, and yeah, that's 8 of them. So 8 out of 16 if you count that up. B is sum greater than 5. Go green again. Sum greater than 5. So these are the sums that are greater than 5. So it looks like there is 6 of them. And now I want to subtract the times that I have an even sum that is greater than 5. So that's both things occurring. And you can see within that green triangle, I have four blue circles, which are 4 even numbers. So that'd be subtracting 4 out of 16. So 8 plus 16 is 14, minus 4 is 10 out of 16, or 5 out of 8. However you want to express that. Again, reducing the fraction is nice because it helps really me correct, or if you're doing future calculations, further calculations I meant to say, but it doesn't really make it a better answer. It is the same value. You could also convert that to a percentage as well. So that is B. Okay, example 3. A vehicle dealership database reports that 56% of the available Honda Accords have heated leather seats. 49% have a sunroof, and 27% have neither. What is the probability of a Honda Accord at the dealership having a sunroof but no heated leather seats? Okay, so I'm going to choose to do this question a little bit differently. I'm going to use a Venn diagram. You could do this question in another method, but the Venn diagram is likely the easiest way to do this. So, the first thing, remember, whenever we are working with a Venn diagram, is we have to see if there's an overlap again. Remember, there's kind of different types. We can have subsets, we can have disjoint sets, we can have an overlap like this. So let's check for this overlap. So the way we do it is we add up our numbers. Now, these are my numbers here. Okay. Now this is percent, so this is really out of 100. So that's why I could make some fractions out of this too if I wanted to kind of keep going with the fraction route. But I'm going to choose to do this a little bit differently. Okay, so I'm going to add those numbers up, and I'd get 132. Remember that however much it's over the total, that's going to be what your overlap is. And we know that these are percentages, meaning they're out of 100. So this should have added up to 100, but it's adding up to 132. So that means I'm going to have some overlap. And the amount of overlap will be the 32. Let's go to red here so it kind of pops. So that's 32. Okay, so we should name these sets. So I guess this will be leather seats. That didn't write. Leather seats. And this can be, what's the other one? Sunroof. Now leather seats, they're supposed to have 56%. So if I go 56 minus 32, I'll get 24. And that would mean leather seats only. The middle is where they have leather and sunroof. And then the far right here, which should add up to 49, that would add up then to 17. Okay, and then we also have 27% having neither, so the 27 would simply go out there. I don't know why I put a percent, but I did. I'll throw that percentage in. So again, this is leather only, this is sunroof only, and then this is both L and S right here. Okay, so what is the probability of a Honda Accord at the dealership having a sunroof but no heated leather seats? 17%. Okay, so this is already in like fraction form. You could say, 17 out of 100. And yeah, so that's just a way you could do this question. Example 4. The results of a recent survey states that 58% of students skip breakfast, 29% skip lunch, and 19% eat both lunch and breakfast. I read that kind of backwards. Okay, again, we're dealing with these percentages, and this is going to be a good time to deal with a Venn diagram because they're trying to describe a whole situation, so I can actually represent it this way. So let's, I guess, get looking into it. So the first thing I want to do, let's make sure I have my blue here, is I'm wondering about overlap. Okay, do I have that overlap? So I'm going to add those numbers. So 58 plus 29 plus 19. And that's 106. So because we're dealing with percentages, we know this should add to 100. It doesn't add to 100, it adds to 106. So then that means in my Venn that is 6. Okay, they overlap. So we have skipping breakfast and skipping lunch. So this will be breakfast, this will be lunch. So breakfast is supposed to add up to 58%. So that would mean this has to be 52 because the 52 and the 6 will make the 58. Skipping lunch is 29, so that means lunch only will be 23. Sorry, my pen isn't writing as well as it usually does. There we go. You can see it's kind of a step behind. It kind of acted funny there. Anyway, that's 23. And then you can see here it says 19% eat both breakfast and lunch. And again, my pen is starting to act funny. So I guess maybe as I was working with the numbers, I might have been saying this kind of backwards. What I was talking about. This is 50. So this is skipping breakfast, and then this is skipping lunch. So again, my pen is acting funny. That's skipping. Now those little circles make me think that they're Venn diagrams. So let me just put. This is what I was just trying to highlight. Those were skipping. So this one here means that they'd skip both breakfast and lunch. And that is possible. Not wise, but it is possible. Okay, so we want to determine the probability that a randomly selected student skips breakfast but not lunch. Okay, so that would mean I have to, like, really, I got to ignore. And again, I'm sorry, everybody. I'm trying to draw lines there. I'm ignoring the lunch circle, so that would mean this would just be 52%. 52% of students, there'd be a 52% chance that a randomly selected student would skip breakfast but not lunch. Then determine the probability that a randomly selected student skips at least one of breakfast or lunch. Okay, so they're using or. So this is where we can add our probabilities and subtract the overlap. So we can absolutely do that. Or if you remember when we're dealing with these Venns, we can simply add those three regions. So I can add the 52 plus 6 plus 23. And that would work out to 81%. There's an 81% chance that a student would skip at least one of those. The other way of doing it, if we want to make it look like the previous kind of work, pen seems to be working a bit better now. I'm using A's and B's there by accident. So that's B, that's L, B and L. So skipping breakfast, there's 58% of kids skip breakfast. It said, or there's 58%, yeah, 58% of kids. 29% skip lunch minus the overlap, which we found out in the Venn to be 6. So there's my Venn. This is where that 6 is coming. If I add that up, you'll see that that adds up to 81 as well. So there's two different ways to do that. Okay, so that is OR situations. Also, you can refer to it as addition of probabilities. I hope that made sense. If it didn't, come see me sometime for clarification or talk to your teacher. Have a great night.